Now for section 6.2, we're going to continue reviewing our work with variables, and this time talk more about equations. So we did a little bit with equations with formulas, but it was more about still evaluating and plugging numbers in. So here we're going to do a little bit different and learn how to solve. So a linear equation in one variable is an equation that can be written in the form ax plus b equals 0, where a and b are real numbers and a is not 0. Now, the thing that I really want you to take away here when you hear linear is notice that there are no exponents besides 1. So technically there's always 1 there, but there's no squares, no cubes, nothing like that. There are no roots or radicals on the variables. There are no variables in the denominator, etc. Now, you can have fractions. Regular fractions are fine, but I mean that there's nothing weird going on with the variables. It's as simple as you can get. So by a variable in the denominator, I mean something like this. Like that would be kind of different, right? So those are not linear. That's a different kind of equation. So your linear equations are your simplest ones. And that's what we're going to focus on here. Now, a lot of times we use the variable x, but it doesn't have to be x. So just kind of keep in mind it could be any variable, but we're just using one variable at a time. And to solve an equation in x involves determining all values of x that result in a true statement. So solutions or roots of the equation are numbers that make the equation true. That's really what we're trying to find here. What number makes this equation true? So for instance, x equals -3 is a solution of this equation, and I know because I can check it. So how do you check something like this? Well, you just plug it in, which we know how to do. So I take that x and I replace it here. Simplify using those order of operations. 4 times -3 is -12. And then -12 plus 12 is 0. Now this is true, right? 0 equals 0. So it is a solution. So a solution is just any number that you plug in and it gives you a true statement. It doesn't always have to be 0 equals 0. It could be 4 equals 4 or 12 equals 12. It doesn't matter. But you get a true statement there. For solutions, sometimes we use the word satisfy. We'll say -3 satisfies the equation, which is just another way to say that it's a solution. And the set of all solutions of an equation is called its solution set. So here, using some set notation that we're used to, we can write it like this to say that that is the solution here. Now, two or more equations that have the same solution are called equivalent equations. And here's an example. 4x plus 12 equals 0, 4x equals -12, and x equals 3 are all equivalent equations because they all have the solution x equals -3, right? If I plug in -3 here, here, and here, they all become true. Now we saw this one already. When I plug in -3 there, I got 0 equals 0. If I plug in -3 here, I get 4 times -3, which is -12. So I get -12 equals -12. And if I plug in -3 here, I get -3 equals -3. So these are all true statements. So -3 is a solution in all of them. And we actually use this idea of equivalent equations when solving equations from the start. So when we have something more complicated where we can't just guess at the solution, we use this process of finding equivalent equations along the way to help us get to the answer. You can see our examples get simpler and simpler. Now, there's a couple more properties that we do use when solving. The first is called the addition property of equality. And it basically says that it's okay to add the same number to both sides of the equation. This is also true for subtraction. So I'll say add or subtract. Because subtracting is the same thing as adding a negative, which is why we can also include subtraction here. Multiplication, same thing. It's absolutely fine to multiply both sides of the equation by the same number. Not 0 though, because 0 just kind of cancels everything out, but anything else besides 0, it will be fine. And it's also true for division. And that's because dividing is the same thing as multiplying by a fraction. So we can incorporate those ideas here. So basically what it says is okay to pretty much do whatever you want to one side as long as you do the same thing to the other side. And that keeps it all balanced. So we can add or subtract on the same side. We can multiply or divide Again, same thing to both sides. Now, when you're solving, you're trying to get x by itself. Okay? That's what you want to do when you're solving. Get that variable alone. So think about how to get that variable alone, right? Now, one thing I like to do, these are pretty simple, but I like to draw a little line on my equal sign just so I can see the two sides. So if I want x to be by itself, I need to get rid of this -3, right? It's in the way. Well, the opposite of a -3 is a +3. So I'm going to use that addition property here, and I'm going to do +3 on both sides. And it's okay, because as long as I do it to both sides, it stays balanced. So -3 and a +3 cancel out, and that gives us the answer x equals 11. Now, I'm not going to check every single equation, but if you go back to the original and you plug in 11, you do see you get 8 equals 8, which is true. All right, for the next one, again, I just want that variable by itself. So I need to get rid of the +7, right? Because it's hanging out with the x. I don't want it to be with the x. I want it by itself. So think about how you cancel things. We use opposites. The opposite of a +7 is a -7. So I will do -7 on both sides. The plus and the -7 will cancel. And then I have x equals -22. Now for my next one, this one's a little bit different. I have 6 being multiplied with x, right? 6x means multiplication. And again, I want that x by itself. So I need to get rid of the 6, right? I don't want that 6 hanging around. Well, the opposite of multiplication is division. So to cancel out the 6, I would divide by 6 on both sides. This leaves me with just x, and 30 divided by 6 is 5. And then finally for this one, again, I want the x by itself, so I need to get rid of this 5 here. It's being divided, so the opposite of division is multiplication. So I'm going to go ahead and multiply by 5 on both sides. And that will allow me to cancel that piece out. So x is equal to 45. So those are our just kind of single one-step examples here.